Hey, what's up? Let's do some math. All right, today we're going to do some word problems, and we're going to write those word problems as equations, and we're also going to fill in tables about them. Okay, and then we're going to graph them. All right, so this is our next step in our functions unit and how we can make connections between words, equations, tables, and graphs. Okay, all right, so let's try this first one here on our notes. It says Aiden has $50 in his bank account and withdraws $10 a week. All right, what looks important here? I would say $50 in his bank account looks pretty important. And then withdrawals $10 a week, right? All right, so what does withdrawal mean? So withdrawal means that you are taking money out of your account. If you go to the ATM and then you put your card in and you type in your code, you might have seen your parents do that. Right? Put a card in, type in your code, and you can withdraw money that's from your bank account. That means you're taking money out of your bank account. Okay? So withdrawal means that you are subtracting. Okay? So our equation is usually in slope-intercept form. So that means that we're going to put y equals first. So it's going to be y equals. So then it says he has $50 in his bank account. So I would say 50. And then we said withdrawals. So withdrawals means minus. So we're going to minus. Well, what are we minusing? Well, we're minusing $10 a week. We don't know how many weeks, right? So since we don't know how many weeks he's withdrawing this for, that is our x. That can change. We can do it for 0 weeks. We can do it for 2 weeks, right? That's going to change in our as our variable. All right, so we have our equation. Let's figure this out. Let's find out some weeks. So at 0 weeks, how much money does he have in his account? Well, I would plug 0 in for 10. 10 times 0 is 0. 50 minus 0 is 50, right? So I would still have $50 into my account, right? Let's see, at 1 week, how much would I have left? Well, in 1 week, I would plug that into here, right? 10 times 1 would be 10. 50 minus 10 would be 40. How much would he have after 2 weeks? Let's plug it in and see. If I plug 2 in for x, 10 times 2 would be 20. 50 minus 20 would be 30. All right, how much would he have after 3 weeks? Well, let's see. Let's plug it in. 10 times 3 would be 30. 50 minus 30 would give me 20. All right, so we filled in our equation, we filled in our table. Now we can make our graph, okay? So our graph, this is just quadrant 1, as you can see. It's not a whole coordinate plane, it's just quadrant 1, because these are all positive numbers right here, right? Both of these are positive. All right, so now we have to label our graph. So our x values are 1, 2, 3. That's pretty easy. We can just go 1, 2, 3, right, across the bottom. All right, but our money here, our y values, this is our y values, this is what it equaled, right? So that's my up and down here. It's going by up to 50, right? So I can't label this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because I can't graph any of those numbers, right? So I have to change my scale for my y values. So what should I change it to? Maybe I can change it to counting by tens, right? So I can make like this one 10, maybe this line 20, this line 30, this line 40, and this line 50. And I can keep going up if I wanted to, if I wanted to keep counting up, but our biggest number is 50, right? All right, so let's plot our points. Let's graph our line, all right? So my first point is 0, 50. So at 0, I'm gonna go up to 50 and put a point. So I got a point at 50 right there. My next one's 140, so I'm gonna go over to 1, here's 1. I'm gonna go over to 1 and up to 40, there's my next point, right? My next one says 230, so my next line would be 2, and then I would go up to 30, right? My next one says 320. So I'll go to 3 and then go up to 20. And you can kind of see it's going in a trend, right? And that's what we learned, that all these should make a straight line because they're linear equations. They have the same slope. This slope is down 10, because technically 50 to 40 is 10, right? Down 10 over 1. And that's what our slope is here. And slope's always with the x, right? So like if I wanted to rewrite this in slope-intercept form, this would be y equals negative 10x. And that's a plus 50, a positive 50, so I'm gonna put plus 50. That's what it would be in slope-intercept form, right? And 50 would be my y-intercept, which was on my y-intercept, right? And then I'm going down by negative 10 over 1, right? So down 10 over 1, down 10 over 1, down 10 over 1. If I wanted to go for like week 4, I know that he's probably gonna have $10 in his account, right? Because he went down 10 over 1. If it was week 5, he would have $0 in his account. He'd be down at 0, right? So he'd be running out of money out at 5 weeks. Okay? So what does this mean? Let's try and figure out our IV and our DV. So weeks is the number of weeks that he's withdrawing. That is our independent variable. Money is our dependent variable. because that depends on how many weeks that he's withdrawing money, right? Like we just said, if he withdraws it for 3 weeks, he's going to have $20 left. If he withdraws it for 1 week, he has $40 left, right? So that the money depends on the weeks. All right, let's go try another one. All right, this one says Abby gets paid $15 an hour to walk dogs. All right, so $15 an hour to walk dogs. Okay, so she has a job. So that means, remember, our equation is always y equals. And if it's $15 an hour, whenever you see this word and, that's a pretty good indicator of where your variable is going to go. So that would be 15x, right? So we don't know how many hours she's going to walk these dogs and get paid. All right, so let's figure it out here. Let's do some. So if she did 0 hours, how much money is she going to get? Well, if she works 0 hours, she's going to get $0, right? What if she worked 1 hour? Well, let's plug that in. If I plug it in for x, 15 times 1 would be 15. What if I did 2 hours? Well, I would plug 2 in for x. 15 times 2 would give me 30. Let's say if she did 3 hours. 3 times 15 would give me 45. Right? So now that I know that, now I can graph it on my line here, right? All right, so once again, you can see that the x values, remember this is our x side, this is our y side, right? My x hours, I can just count 1, 2, 3, 4, right? Like that. But my y values, I can't just count by ones because I wouldn't fit on my graph. So I got to figure out how could I graph this and go up at the same time, right? So maybe I can do by tens again. Maybe I can do 10 on this one, skip a line, do 20, skip a line, do 30, skip a line, do 40, skip a line, do 50. That would work, right? And then each line, so like this would be 5, 15, 25, 35, 45, 55, right? Okay, so now we can graph our equation, right? So at 0 hours, she had $0, right? She didn't work. You don't get any money if you don't work. So that'd be 0. What about at 1? At 1 hour, she had 15, right? So I would go up to 15, put it up. What about at 2 hours? 2 hours, she would be at $30. What about at 3 hours? 3 hours, she would be at $45. If I went to $4, that would be up here at 60, the next line that's not on a graph, right? You're going up $15 each hour. Okay, so what's our independent variable? Well, our independent variable is the amount of hours that she worked. What's our dependent variable? Well, our dependent variable is the money, because that depends on how many hours she works, right? If she works 3 hours, she's getting $45. If she works 1 hour, she's getting $15. So your money depends on how many hours that you work. All right, let's do one more example, and then you guys are going to try one on your own. Okay, this one says 4 less than twice the input is the output. So is in math means equals. So is the output means that it's going to be y equals. And that's normal like all of our other equations, right? All right, then it says 4 less than. 4 less than. So this less than is a key word here. All right, from, than, to, switcheroo. That means that this 4 is going to get moved behind whatever comes after it. So you have to find twice the input first and then 4 less than that, right? So we're going to end in -4. Then it says twice the input. So twice the input, twice means you're timesing something by 2, and input we know is our x values. Okay? So now we have our equation. So now we can plug it in. So we can plug in any numbers you guys want. You can plug in 0, 1, 2, 3. You can plug in -1. Doesn't matter. Plug in any numbers you want, and now you just plug them into x and figure out what it is, right? So if I plug 0 in, 2 times 0 is 0. 0 minus 4 is -4. If I plug 1 in, 2 times 1 is 1. Minus 4 would be -2. If I plug 2 in, 2 times 2 is 4. 4 minus 4 is 0. If I plug 3 in, 2 times 3 is 6. 6 minus 4 is 2. And now I got some points, right? So now I can graph it, right? I could graph it using slope-intercept form, or I can graph it using the table, right? So 0, -4 is my first point. It's right there. 1, -2. 1, -2. 2, 0 over 2. 0, that means I don't go up or down. And then 3, 2. So I go over 3 up to 2. And I could have done this by using slope-intercept form the same way, right? I would use my y-intercept, -4, And then my slope is 2, so that means 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. What would it be if it was 4, right? If x was 4, what would it be? Well, I can figure that out because I know my slope, up 2 over 1. If it was 4, my y value would also be 4. What about if my x value is 5? Well, I can figure that out because of my slope, up 2 over 1. My y value would be 6, right? So you can graph it either way using the table or equation, but it's good to know that you can go between both, okay? All right, let's go on to the last one. All right, last one says Larissa starts with $5 and deposits $2 a day. All right, so my equation's always y equals. All right, she starts with $5. She starts with $5. And she deposits $2 a day. So depositing money means that you're adding money into your bank account. So that means that she's adding $2, and then it says a day. So we don't know how many days she's doing this for, right? So that's my x. So deposit means I'm adding $2 a day. A day, we don't know how many days, so that's our x, right? I could rewrite this in the slope-intercept form too if I wanted to. So remember, slope-intercept form is y equals mx plus b. Well, that would be 2x would go first, and then my b, my y-intercept is a positive 5 here, so it would be a plus 5. All right, go ahead, pause the video, fill in this table. See if you can do it. All right, hopefully you pause the video and fill in this table. All right, so then now I could graph my numbers here, right? So my x values are over here on the left, remember, y values over here on the right, right? So at 0 days, she has $5 because she started with $5. So I can go from 0, 1, 2, 3, 4, 5. That would be up here at 5, right? At 1 day, she had $7. So 1 day, she had 7, 6, 7. Right? At 2 days, she had 9. So at 2 days, she had $9. Right? Right? And like I said earlier, you could do this at 3 days, and she'd have 11, which would be off our graph. It would be like our next line up, right? Which isn't on there. So you don't really have to graph. You don't have to graph that one because it won't fit on our graph. Okay? But you could also graph this by using slope-intercept form, right? So plus 5 is my y-intercept. So I would put that first. And then I would use my slope of 2. 2 is 2 over 1, right? So up 2 over 1, up 2 over 1, up 2 over 1, right? Okay, so what is my independent variable? Well, my independent variable is the days she deposits, right? Days she deposits. So what's my dependent variable? My dependent variable is my money, once again. Because depending on how many days she deposits, depends on how much, that depends on how, the money depends on how many days she deposits, right? Okay, so that's word problems and how to go from a word problem to an equation and how to fill in a table and make a graph. And we reviewed IV and DV as well, okay? All right, if you ever have any questions, you can always ask a teacher, and I'll catch you next time. Bye-bye.